Okay, so we know that lunar and solar eclipses don't occur every single month, but only during a narrow window of the year. But when they do occur, let's try to understand why these eclipses happen at all. Let's first talk about a lunar eclipse. This is a shadow simulator. So here's the sun, here's the Earth, and here's the moon. And you'll see these shadows look a little complicated. The very darkest part is where you're in a complete shadow. That is, the sun is completely blocked. So that's true of the moon as well here. The sun is completely blocked in this little shadow. This light gray area is where the sun is partially blocked. So if you were in this gray area looking at the sun, you'd see that some of it is just blocked by the sun, but the rest of it you can see, right? So it's a partial eclipse area. Okay, so a lunar eclipse, when we have a lunar eclipse, what that means is that the moon in its orbit has landed in the shadow caused by the Earth. Right? So if you imagine normally when the moon is in this orientation, most of the time we see the full moon, right? But if it happens to be during that small eclipse season, when the moon passes here, right, it starts to get a little bit, that full moon starts to get a little darker as it passes into this partial eclipse area, and then the full moon almost completely disappears for a few hours as it passes through this really dark part of the shadow, and then it emerges again and gets slowly brighter, brighter, brighter. Now this is all exaggerated. This whole thing, this whole process takes maybe 4 or 5 hours, right, as it orbits around, and it's always happening when the moon is a full moon. So it's a really extraordinary thing, right? This bright full moon basically gets turned off over the course of a couple hours and then turned back on. You can imagine that ancient people maybe have been freaked out by that. But even Aristotle understood what was happening. He knew that the moon was passing through the shadow of the Earth. That's a lunar eclipse, all right, because the moon is in a sense turned off. Now, a solar eclipse would be the moon keeps orbiting around, and the moon gets right down here between the Earth and the sun. And so you could see for a solar eclipse, what that means is that the moon is perfectly blocking out the sun. But you'll notice that that would only happen for a small little stretch of land on the Earth. I mean, for a larger area on Earth, we'd see a partial solar eclipse. Again, this is exaggerated, so the whole Earth wouldn't see a partial solar eclipse. But if you happen to be up here somewhere, you'd see a partial solar eclipse. But if you happen to be right where the darkest shadow of the moon is on the Earth, you would see a total solar eclipse. That is, the sun, imagine that, in the middle of the day would just disappear from the sky, right, and be dark as the moon passed in front of it. I mean, that's crazy, right? I mean, that's a really extraordinary thing that happens. So it would be a solar eclipse, but you'll notice it happens only for a very small location on the Earth, and it happens for a much shorter time. It would only happen for any observer, they would only see it happening for like a few minutes. All right, so it's much more rare for someone to see a total solar eclipse than it is to see a total lunar eclipse. For one reason, the total lunar eclipse lasts a lot longer, several hours. The other thing is that everybody on the right half of the Earth here sees the same moon, and so when the moon passes through the shadow, everybody on this whole hemisphere of the Earth sees the eclipse. Whereas for a solar eclipse, it happens for such a brief amount of time, only a few minutes, and it only happens in a very specific part of the Earth. I want to show you this because it's really quite extraordinary. Okay, here are some real pictures from space of solar eclipses. You can see here this shadow is very localized, right? This is the moon's shadow on the Earth blocking out the sun, and only a very small part of the Earth is actually seeing that. I mean, the very dark center is where people see a total solar eclipse, and the lighter gray is where people are seeing a partial solar eclipse. It's really amazing. Here's another picture from the space station. I mean, look how extraordinary this is. That for this little patch of Earth, they're experiencing a total solar eclipse. So it's quite rare in the sense that we don't see total solar eclipses on the United States or the Midwest, not necessarily all that often. You know, a solar eclipse may happen maybe once or twice a year somewhere on the Earth, but the chance of that happening in North America is pretty rare. In fact, the next time a total solar eclipse happens in the United States is going to be 2017. So here's one more cool picture of that eclipse hitting the Earth. In fact, here's one other one. Pretty amazing to see. Now, what do these eclipses look like if you're actually on the ground looking up at space? Well, let's first look at a lunar eclipse. And maybe you've seen one of these up close and personal. So, again, this happens over the course of many hours. And so you'll see time kind of ticking away here in the upper left. The moon's passing into the Earth's shadow, right? And then eventually the whole full moon is like turned off. And we'll usually see it look kind of reddish. And that's because there's a little bit of light leaking through around the edges of the Earth's atmosphere. But it's hard to overestimate how dark it really is. Even when it's red like this, it's really very dark on the sky. I mean, it's like the moon just disappeared. Okay, and then it slowly comes back out of the shadow and we can see it again. It's pretty extraordinary, but not quite as extraordinary as a solar eclipse. I want to show you what this looks like. This is like amateur footage showing a bunch of people are out looking at the solar eclipse. Okay, so you can see that this is what normal life looks like. It's the middle of the day, but the sky is dark, and he's going to zoom in as you see what the sun looks like. It's crazy. The sun is gone. All you see is this glowing corona, which is like the atmosphere of the sun shining around the moon. It's really extraordinary, and this happens only for a couple minutes, and it's like you could see stars in the middle of the day. So really quite extraordinary when these eclipses happen, and hopefully now you have a better sense of what the geometry of an eclipse is and how rare, especially a total eclipse is for to see it, say, in Michigan.